Our next speaker is Raja Jurdak. He's a professor of distributed systems and chair in the applied data sciences from the Queensland University of Technology. He's also a director of the Trusted Network Lab. He received the PhD in information and computer science from the University of California. He previously established and led distributed sensing systems group at CSIRO at Data 661, where he maintains a visiting scientist role. He's also spent time as a visiting academic at MIT and Oxford University in 2011 and 2017. His research interests include trust, mobility, and energy efficiency in networks. Professor Jurdak has published over 215 peer-reviewed publications, and including 2 co-authored books, which most recently on blockchain in cyber physical systems in 2020. His publications have collectively attracted over 9,750 citations. He was named among the top 0.9% cited researcher globally for the calendar year 2019. Stanford University in 2020. He serves on the editorial board of Ad Hoc Networks and Nature Scientific Reports, and on the organizing and technical program committees of top international conferences, including PERCOM, ICBC, IPSN, WOM, and ICDCS. He was TPC co-chair of ICBC in 2021. He received the Embark Fellowship in 2006 and Endeavor Fellowship in 2011. He's the conjoint professor with the University of New South Wales, a senior member of IEEE and IEEE Computer Society Distinguished Visitor. Let's all welcome and give him a warm welcome for the next session on blockchain in supply chain. Enjoy the session. Thank you.
Good morning. It's great to have this opportunity to give you this talk about our work in applying blockchain for supply chains and looking at some of the opportunities and design challenges in that space. My name is Raja Jurdak. I'm a professor of computer science at QUT and also chair in applied data sciences. So why would we use a blockchain in supply chains? Some of you might have already heard of some of the early adoption of blockchain in supply chains. Essentially, for a supply chain, you have a lot of data sharing among multiple stakeholders, but the assets and their ownership are being transferred through the supply chain. And that opens up certain problems about tampering with products, counterfeit products, contamination, for food and medicine, for instance, spoilage, such as not keeping products in the right conditions. So there are lots of issues that can arise as products traverse the supply chain. And the purpose of using blockchain in that context is to improve the traceability and transparency about what's happening to the products as they traverse the supply chain. Traditionally, a lot of the data has been collected in centralized databases, but there are some disadvantages to this approach. So when you have a centralized database, you're actually giving a lot of power to the owner or manager of the database, which lacks transparency. So you don't really know what's being shared or how much of it is being shared. That might lead to some issues, and giving a lot of power to that database owner might lead to data misrepresentation or even corruption in some cases. It also creates complexities around payment processing and also makes scaling operations to global scale difficult, particularly in complex supply chains where you have a lot of relationships that need to be captured and a lot of data to be collected from that context. So here's where blockchain comes in for supply chain management. Now, blockchain has been used for many different applications. whether for agricultural automation, smart transportation, in conjunction with technologies such as Internet of Things that collect sensor data from the physical world and make it available in the digital realm. And you can put that data on the blockchain to ascertain that certain physical events have happened, and you can trace them over time to track the condition and location of products across the supply chain. So the first problem we looked at was publishing and subscribing to data within a supply chain. Traditionally, this publish-subscribe model uses a broker. So you have publishers that publish data and subscribers that subscribe to certain topics, and the broker that sits in between that ensures that published data is available to subscribers. The benefits of this approach is that the broker isolates data producers and data consumers. And it also has a one-to-many message distribution. So publishers only need to send data to the broker, and then the broker is responsible for ensuring that subscribers that are subscribed to this topic can access the data. However, there are problems with this approach. The problems are you have a centralized trusted broker. So what if that broker breaks? Or what if that broker is compromised through hacking or other methods and is no longer honest? So that single point of failure represents a vulnerability in this approach of the traditional publish-subscribe approach. It's also susceptible to what's known as Byzantine failures. So there, organizations may choose to withhold or manipulate data, and that means that the data is no longer persistent in the system. So that is another problem. And the major reason why this is a problem is that many real-world applications, such as supply chains, involve multiple stakeholders. So why would we centralize power and centralize all the information flow through one entity when we have multiple entities that are both cooperating and potentially have certain competitive relationships when it comes to business? So here we proposed the Trinity System that was led by one of our research fellows. So in the Trinity System, it superimposes a distributed ledger, which is a blockchain, on top of this publish-subscribe model. So the way it works is you have the traditional publish-subscribe model that's shown here over many instances, but associated with each broker in that publish-subscribe model, you have a consensus node. So that consensus node actually talks to other consensus nodes from other brokers or other domains in order to agree on what data has been added about the supply chain. So here we're eliminating the single point of failure and ensuring that the data being shared on the supply chain is not only stored and managed by one broker, but is shared and agreed upon by these consensus nodes and then stored on the blockchain. So that if one of these brokers or domains are faulty or withhold data on purpose, then the data persists for the purposes of the supply chain. And you can read more about this paper in that, about this work in the paper that's referenced at the bottom of the slide. There's also an open repository, so the software for this is open source and can be used for various applications. So this was about ensuring persistence and eliminating the single point of failure for data in supply chain. Now let's look at how to make supply chains more transparent, trustworthy, and privacy preserving with blockchain. And I have to acknowledge my former PhD student, Dr. Sidra Malik, for a lot of these slides, and this was part of her PhD. So there, some of the problems for supply chains are how to ensure provenance of products, as you very well know in this forum, and also how to trust the data and information that's coming from the supply chain. There are also issues with privacy. So in a business context, supply chain stakeholders won't want to share all the data to provide transparency. They might want to withhold certain sensitive data, such as the methods or location of production or transport of the goods, or they may want to withhold identities of certain players for business reasons. So what this creates is it actually creates a bit of a tension between the need for traceability on one hand and the need for protecting that sensitive data on the other hand. And in this work, we looked at some of these challenges, including provenance, trust, data, and identity privacy. And we looked at all of that using a blockchain system for supply chains. So what are the challenges for each of these? For provenance, it's important to have a governance model for a supply chain and to be able to scale so that as the supply chain grows, the IT infrastructure can grow with it. For trust, it's important to have accountability and reliability of the data and the stakeholders. In terms of data, we need to maintain the rights of stakeholders to own their data. And in some cases, these owners might also want to maintain their identity secret for those business reasons. So we propose different solutions to solve the problems that we saw on the previous slide. And they're called product chain for provenance, trust chain for trust, priv chain for data, and trade chain for identity. And the next few slides, we'll go through these and discuss them briefly. So product chain started by looking at the basics. So it was looking at how do we ensure governance and access control, and how do we define transaction vocabularies for blockchain-based supply chains. So it defined a consortium blockchain where the participants are defined, and there's access control rules defined for what each participant can access in terms of data, what their roles are within the permission or consortium blockchain. It also defined a network model, which used a global ledger or a global blockchain, but also used side chains to manage different participants that may be in different geographical areas so that it's more scalable. Product chain also defined supply chain specific transaction vocabulary. So it has transactions that allow stakeholders to produce an asset and put it on the blockchain. It also has transfer of ownership and processing transactions that allow both selling and buying items, but also manufacturing and combining different items to make one composite item. So what it provides, it enables provenance of a product, and we can look at it through a use case. So in this case, we have chocolate that's sold to the consumer. Now, with a QR code, the consumer can, for instance, scan it and submit a query. Then that query goes back to the blockchain and works back to the different stages that this product's been through, looks at the different transport legs that it's been through. And also because chocolate is a combination of milk and cocoa beans, so there's a split here in the information trail where you can follow the different stages in terms of the supplier and the producer of the milk, and similarly for the cocoa. So essentially, product chain provides provenance of the journey of the product from production to consumption. So product chain actually solved some of the problems for us, including farm-to-fork traceability, scalability, and ensuring there's a consortium blockchain, but it did not guarantee trustworthy data. So here's where we want to make sure that the data we put on this blockchain, which is an immutable ledger that is shared among the different participants, that this data is trustworthy. Otherwise, we have the problem of garbage in, garbage out, meaning that if we store fake data or unreliable data on the blockchain, then that's what we're going to store over the long term. So we really need to trust what data we're putting there, and that led us to add more functionalities on top of product chain. And that led us to the trust chain architecture, which has 3 layers, including a data layer, a blockchain layer, and an application layer. So the idea of trust chain is that you need to take multiple data sources into account, including sensor data from IoT devices, regular checks by regulatory bodies, and the input of traders. You need to combine all these different data sources and store the reports on the blockchain so that you can make decisions about who to trust and how much to trust them based on all this evidence that's available. So that's what's done on the data layer. And then at the blockchain layer, we maintain a module that can track the reputation and trust of the different participants and of the different products over time based on these multiple inputs that we get from the data layer. And finally, at the application layer, we can query the data in the blockchain similarly as we did for product chain, but there are also rewards and penalties for when participants act honestly and their reputation increases. There are rewards within the system and penalties also that their reputation drops if they behave dishonestly. So that tackled the trust issue in terms of trust chain. It provides multi-source data, automated some of the trust, provided granular information about both products and traders, but it did not solve the problem of privacy, which we look at next. So for privacy, we have a permission blockchain system that can be shared among many stakeholders. It exposes things like trade flows. It may expose other trade secrets. There are some solutions we can use to solve this, including private channels, encrypted data, and anonymous transactions, which are part of the toolbox to address some of these privacy issues. And there are a couple of solutions one can look at. You can look at hiding data, so hiding specific details about a product that you don't want to reveal for business sensitivity reasons. And you could potentially hide identities when you don't want to reveal all the stakeholders in your supply chain. So for hiding data, we provide proofs on data rather than showing the data itself, and we call this priv chain. And in this approach, again, we have this typical supply chain that goes from producer, supplier, manufacturer, transport to the retailer. And here we rely on some cryptographic primitives. One of them is called zero-knowledge proofs, which is cryptographic methods in which a prover can attest to a verifier that some secret information is true without revealing any details about the secret. And there's another mechanism we make use of called Pedersen commitment, which is a secret sharing scheme where a user can commit to a secret, send the verifier a commitment to the secret without disclosing the secret itself, and then the secret is shared with the verifying at some later point in time. So using these tools, we have the privacy-preserving architecture, and let's take a look at how it works. You have supply chain participants that receive public parameters from the blockchain. Then they can prove certain attributes about their products and store the proofs on the blockchain. These proofs, for instance, proof of origin, region of origin for a certain product, can be verified cryptographically without revealing the private data of the producers or supply chain participants. And then they can be rewarded for providing that proof through a bank. And that also allows a consumer to scan a code on a wine bottle, for instance, to verify that that wine bottle is from a certain wine producing region in Australia without necessarily revealing the exact details of where the vineyard is within that region. So that's the idea, is to prove attributes without having to prove detailed data that may be sensitive. So now let's look at trade chain, which allows us to hide identities. So here we separate the identities from the trades themselves. And we do that by having two blockchain ledgers. One is called an identity management ledger that stores identities, and another one called trade management ledgers that stores trades. And the idea is that traders can get onboarded. So they get on board the identity management ledger, and then they can start logging their trades on the trade management ledger. And whenever a requester wants to know something about the product or the trades, they can request a token from the trader. And then if the trader agrees to sharing that information, then they can go back to the query smart contract, which is automated code running on the blockchain. And then that information can be fetched from the trade management ledger. And here we're just seeing how this token-based querying happens. So a requester first would request a token from the trader or provider. And then the trader or provider checks the request and grants a token if they agree to giving access to that data. Then the requester can query using this token. And they query the trade management ledger, which has its own validator nodes that are running this ledger. Now that query, if that transaction is approved, it triggers a query smart contract that fetches the data from the trade management ledger and filters any sensitive data, and then shares the results with the requester so that the requester can get access to the information that's been authorized by the trader or provider. So in this way, the trader or provider can hide their identity using pseudonyms, such as cryptographic keys for their identity, but sharing specific aspects of their trades that they want to authorize. So thanks for listening to the description of our technical work. I wanted to use just the rest of the time we have today to explore a couple of questions with you yourselves as experts in the supply chain community. And where we see things going forward. So one challenge that has occurred to us in discussions with many supply chain experts so far is that how do you actually ensure that the products that are being represented on a digital ledger are actually the physical products that are being claimed to be those products? In other words, assume I put a sensor or a tag on a product to identify it uniquely. Well, what if somebody removes that tag and puts it on some other product just to have a counterfeit product? That means that the digital identity that I have for the product is no longer mapped to its physical identity. That could be a problem. And that's led many researchers to start looking at, are there some unique characteristics, whether physical, chemical, or even biological, that we can measure that can guarantee the authenticity of the product that we're tracking digitally. So I would love to get your thoughts on that point in the discussion part of this session. And a second challenge that we've identified is interoperability among different supply chains using blockchain. So obviously with blockchain, we want to provide transparency of what's going on in the supply chain and have it in an immutable way that's shared. Without a single point of failure. However, when you create one supply chain with that system, you also create a silo that you can't necessarily share with another supply chain. And we've seen recently with major supply chain disruptions for various reasons, including COVID or the Russian invasion of Ukraine, is that there's lots of shocks to the supply chain. And in many cases, sharing data about what's going on in the broader ecosystem, not just within one supply chain, might be useful. So it's interesting to get your thoughts about how relevant that is for your industries, and also what do you think is the best way to share data among different supply chains, and are there any particular challenges that you foresee there? So with that, I'd like to thank you for listening, and I look forward to a great discussion.
Wow, that was a very insightful presentation, Professor Raja Jurdak, and thank you for making time for the question and answer on your presentation. I must apologize that I couldn't sort of get your last name right. So when I was introducing, I just said Jurdak. So I don't know whether it is right or they should be correct. So please, I apologize. Yeah, look, I think the unpacking this whole mystery of blockchain, I think, has been on the forefront of a lot of the supply chain professionals. They've heard about blockchain in many different forums and conferences like this and so on. So I think here it's a face-to-face now, just to get some direct sort of response on these this particular mystery. Let's see. We got a couple of questions which we have for you from the audience. The first question I may direct, if that's okay. Who typically drive blockchain initiative in supply chain, or is it a third-party service? And if you want to get in there, then you engage with them separately and that sort of thing. So could you please give us a kind of a perspective on that?
Sure. Thanks for the question, and it's great to be here and talking to the community. So that's an interesting question. I think there are some providers, third-party providers, that do provide a blockchain service. Now, with these providers, I think a degree of caution is needed, because the whole idea of blockchain is that you don't have to necessarily rely on a third party, an external party, to intermediate the interactions among the stakeholders in the supply chain.
Excuse me.
And when you do involve that third party, the question arises, do you really need a blockchain when you're putting all your trust in that third party to manage the technology and the data for you? So even if they are using a blockchain, they are sort of relaying all that information to the blockchain. And that, again, creates decentralization, and it defeats the purpose of using a blockchain in the first place. So in many cases, it is the ideal approach is to have the platform providers provide the platform, but that the platform itself can be managed by the stakeholders, so that there's no continuous dependence on that provider being involved and looking at the data or managing the data. And that way you do realize the benefits of blockchain, which is that the stakeholders in the supply chain can then agree on the access rules for their own supply chains, what works for them, and build it or customize that platform that might be provided by one of those providers.
Thank you for that. I have another question which kind of flows on from your response, what you said about dependence on the third party and so on. What are the intellectual property consideration for the data contained in and across this blockchain system? So would you please give some thoughts on that?
Definitely. So there is, as most of you would know, lots of regulation that's coming in many jurisdictions about data ownership and data privacy. The most well-known one is the European Union GDPR, which is colloquially known as the right to be forgotten. And I think in terms of the data ownership, it can be in conflict in some cases with the use of blockchain, because the data may be contained on multiple servers that are owned by the different stakeholders in the supply chain. So ways to get around that is, for instance, to encrypt the data and selectively disclose portions of the data that the owner might want to disclose to their partners in the supply chain, for instance, based on a token that they grant and based on specific requests that they get from the stakeholders. So there is some tension there in terms of keeping your data confidential and using a blockchain, but there are also workarounds that preserve that confidentiality, but achieves a degree of transparency of the data for the benefits of the participants.
All right. Look, I think that's the only time we had for these questions. They were very important questions, nevertheless, and thank you for your response and being open about how the adoption of the blockchain can be seen in the coming years. So thank you very much, Professor Raja Jurdak, for your great presentation and also taking time to provide us, be part of this Q&A session.